Hi everybody. I wanted to go over a couple more examples where we solve logarithm and exponential equations. So here we have 7 times log base 6 of 4x plus 5 equals -2. And when we solve logarithmic equations, we first want to, especially if there's one log, we're going to want to isolate the logarithm so it's a single log. So we can do that by subtracting 5 to both sides and then dividing by 7. So I'll have log base 6 of 4x, let's just take our time, equals -7. Divide both sides by 7. And is -1. And from here, we have a couple ways that we can solve this logarithmic equation. If we're just continuing with what we're learning in this section, the way that we're going to want to approach this is to realize that, hey, I have a logarithmic equation. I want to undo the logarithm to get to the 4x. To undo that logarithm, you convert it to an exponential. So this is going to be 6 to the -1 equals 4x. So the base of the logarithm becomes the base of your exponential. Remember, the logarithm is equal to the exponent, so that's why -1 went to the exponent, and 4x, the argument of the logarithm, is what it's going to equal. So to finish solving for x, well, 6 to the -1 also is 1 over 6 equals 4x, and then multiply both sides by 1/4, and we get x equals 1 over 24. And you don't need to necessarily check your answer now, but you still would want to get into a good habit of doing this. The reason is the domain of the logarithmic function is the argument has to be greater than 0. And so if we do that quick check right now, we're going to see that seven log base 6 of 4 over 24 is 1/6, which is supposed to equal -7. And then if you convert log base 6 of 1/6 to evaluate that, this is -1, and so -7 is -7, so it checks. So again, you still want to get into this habit for checking your answers for logarithms. Alright, now here we have a exponential equation. I know it's an exponential equation because the variable is in the exponent. And similarly to logarithmic equations, you want to isolate the logarithm, and same here, we want to isolate 10 to the 2x. So I'll subtract 1 to both sides and divide by 4. I'll have 4 times 10 to the 2x equals 20 minus 1, 19. Then divide both sides by 4. 19 over 4. I don't care if it's a fraction, I would prefer to keep it as the fraction. And the way that I want to solve for x, again, just based on what we've learned in this section, is here we have an exponential. Let's convert it to a logarithm. So the base of the exponential is the base of the log. The argument is going to be what the exponential equals. And then because if the logarithm is an exponent, it's going to log base 10 of 19 over 4 is supposed to equal 2x. And then we need to solve for x, divide both sides by 2, and we'll have log base 10 of 19 over 4 all divided by 2. And And this is a nice answer. It's an exact answer. If we were still going to get our calculator out and punch it in, make sure that you keep this fraction in parentheses and not get it mixed up in dividing all of it by 2. So let's see, log 19 divided by 4, all divided by 2. And so if we round this, it's going to be 0.338. And so, again, it's better just to leave it as that exact form. In the homework, just make sure you're reading the directions to make sure how they want the answer expressed. Alright, I hope you found these additional 2 problems helpful, and I'll see you in the next video.